Okay, today we are going to look at an important area for most science courses, and that is significant figures. Now, when we look at our numbers, we sometimes have to put them in scientific notation. Scientific notation is a method of writing out numerical values. It simplifies numbers that are really large and numbers that are really small. Why? Because if we had to write out some numbers that had 11 zeros, that would take a very long time, and it would get to be very inconvenient to write it out all the time. So, for example, we have the mass of the Earth. The mass of the Earth is 5.98 times 10 to the 24th kilograms. So if you had to write out that number, you would have 22 zeros. If we were doing calculations, you would have to write that out on each line, and that would take a long time. So this is just kind of a shortcut that allows us to have a quick way of writing really large or really small numbers. Now, there are some amounts that we use frequently that we give their own name and their own prefix to. So things like megs, you may have seen on your computer, you're talking about how many megabytes it can hold, or gigabytes, or now even terabytes. So there are some that are fairly familiar to you. These we will be using periodically. So when we look at numbers, specifically when we're in a lab and we are measuring and gathering data, we have to be very careful to make sure that we are reporting accurate information. So there are some rules that we have to follow. All non-zero numbers are always significant. All zeros between non-zero numbers are significant. All zeros to the right of the decimal point and at the end of a number are significant. And all zeros that are to the left of a written decimal and are in a number greater than or equal to 10 are significant. So, one thing we might want to see is, can we remove the zeros when we're writing it in scientific notation? If we can, the zeros are not significant. So if we look at some examples here, we start with 48,923. There are 5 significant figures here. And we are using the first rule, which says that all non-zero numbers are always significant. Our second number, 3.967. There are 4 significant numbers for the same reason. Our third line, we have 900.06. There are 5 significant figures. We've got the non-zero numbers. We have the zeros between the non-zero numbers, and the zeros that are to the left of a written decimal point. If we look at the third line, 0.0004, we have that the non-zero number, the 4, is significant, but we can also remove the others using our scientific notation. So there's 1 significant figure there. Our next number, 8.1000. There are 5 significant figures based on rules 1 and 3. 501.040 has 6 significant figures based on all 4 rules. If we start looking at the bottom, you notice now we can start writing things with scientific notation that can remove a lot of zeros. So there's 1 significant figure in 3 million, and there are 3 in 10.0. So we have to be careful we include the accurate number of significant figures in our calculations. So when we are adding and subtracting values, we need to make sure that we do not portray an answer that is more accurate than what we can really get. We are only as accurate as our least accurate measurement. So our answer cannot contain more places after the decimal point than the number that has the smallest amount of decimal places. So if we were adding these three numbers, we have 23.11324, 1.154, 0.2532. Now, if we look at the decimal points, we have 5 after the decimal point here, we have 3 here, and we have 4 here. So that means the most we can have is 3 decimal places. That's the most accurate we can get with our addition. So if we were on a calculator, our sum would be 24.52044. With our knowledge of our correct number of decimal places, we can get 24.520. That is the most accurate we can get. Now, if we're doing multiplication and division, with multiplication and division, we have to count the number of significant figures for each value. The answer cannot be more significant, cannot contain more significant figures than the number with the least amount of significant figures. Again, we are only as accurate as our least accurate measurement. So if we were multiplying these values, you will notice that our value with the smallest number of significant digits is the middle one. It only has 3. So that means we can only have 3 significant figures. So if we multiply this on our calculator, we get out to 3, 6, 9 decimal places. We have to round to 3 significant figures. So our answer would be 6.73. So you will want to look at your notes in class